All right. Hello, everyone. Good evening. Welcome. Oh, I just realized I got to put my slides up. I haven't actually done that yet. Good to see everyone. While we're getting set up here, feel free to say hello in the chat. Been only a couple of days since I saw you last, but if you have any updates to share with anyone, feel free to put it in there. And we're going to get it going. Hey, Anna, Justin, Narun's here. Excellent. Good to see you guys. Katie, hello, hello. All right, I'm gonna make this big. All right, so we have officially reached the portion of our Cram season where we are done, quote unquote, with content. So this will not be a, hey, let's review all the content we need to know stream. This will be a, let's look at some rubrics, sample problems. Some of you guys sent in sample answers. Thank you to those of you that did that based on the email I sent the other day. So, as I mentioned, we're big picture wise, we are done with the content. Test is units 1 through 7, and that's what we've done so far. So at this point, it's time to start practicing mixed free response questions. Today, we'll look at the ones that I sent you guys yesterday. Excuse me, I got 3 of them queued up, and then we'll see how long that takes us and talk about rubrics and kind of how you scored. And then on Monday, my plan is to not release the questions first and give you timed practice. So come paper, pencil, or with a Google Doc ready to go for you to type answers, and we'll do like a mock test almost. I'll plan 2 questions, one a little bit longer with maybe 6 or 7 parts, and one of them a little shorter with maybe 4 or 5 parts to give you guys a chance to practice answering real questions under timed conditions. And then, of course, at this time next week, I will be probably exhausted because we will be finishing up our 5-hour Cram finale. You guys should all have access to that. That'll be exciting. And then 8 days from now, you will be done with AP Statistics. Woo woo. So tonight, as mentioned, we're going to look at the mixed problems. The problem set, I'm going to put that link into the chat again in case you haven't gotten a chance to look at it yet. You're welcome to pull it up. I'll also have the problems displayed as we talk about them. But my plan is to use some sample answers that some folks sent in and just kind of discuss how rubrics are usually built and all that kind of stuff. So our first scenario was about a group of randomly selected students at a large high school, and you're given a survey. So I can imagine there's definitely going to be some kind of setup next week where there's either some kind of survey or some kind of experiment described to you. And so I tried to model some stuff off of that. But one of the questions asked for the primary mode of transportation. Another asked students for the typical number of minutes it takes them to travel to school. 2 groups of students are singled out, those that said they walk to school and those that said they drive to school. 2 histograms below show the distribution of travel times in minutes for the 2 groups, though the group labels are not present. There are a similar number of students in each group. And here are your histograms. You got histogram J and histogram K. So you take a look at those. I see histogram J is pretty skewed to the right. Got a lot of stuff over in that 0 to 10, 0 to 8 range, but not a lot of stuff above that. Histogram K is very much skewed to the left. And so that was the basis of the scenario. And then here were the 5 prompts that we came up with. We'll just go through one by one. Just a quick... hang on, let me just do a quick poll here. Have you prepared answers in advance of tonight? Just a quick yes, no, or yes, some of them, no. Just a quick poll so I know what we're working with. So I just put a poll up there. Please go do vote on them because I want to make sure this time is like the best use of time for you. Okay, I got 3 votes so far. All right, well, thank you to whomever said yes, all of them. I appreciate you. Okay, woo, got more nuns than I was hoping. Okay, hey, not to worry, guys. I understand it's a very stressful time of year, so I am not. Don't worry, I'm not upset at anyone for saying no. I appreciate your honesty. So I think what I'll do, and with apologies to whomever kind of came in ready to go, let me set a timer here for about 5 minutes just to give you guys a chance to at least start thinking about some answers. Katie, for these, there's going to be one question that's 25 minutes, one that's 15. I think these are good examples of maybe the 15-minute questions, give or take a few. So typically, you would have 12 to 13 minutes per free response question, and it would have either parts A through C or parts A through D. So to add 2 or 3 more minutes to that to get it to a part E, I think is fair. So I'm not going to give a full 15 minutes for this, but let me set a timer for 5 minutes, and then we'll come back and start talking about answers. So maybe start skimming and coming up with some basic things. And again, you can see both the question stem and these questions on the link that I dropped into the chat a couple of comments up. So setting myself a timer for 5 minutes. And well, I guess I'll just wait. So I'll see you guys in 5 minutes. Oh, that was the wrong video to close. My apologies. Thought I was closing my video. All right, we're going to come back on here in about 30 seconds. 30 seconds to wrap up whichever one. I know you might not be done with all 5 parts, but you've at least gotten a chance to look at the scenario. I see some answers coming through in the chat box, so I appreciate that. Just a couple more seconds here. All right. All right, so parts A and B, I'm definitely seeing some good stuff. But I want to show you a question that I drew this inspiration from. So like a similar kind of scenario that had 2 histograms like this. You had to pick a group, and then in part B, it asked how the groups would look if they were combined. I think a lot of the answers I'm seeing right now would get partial credit and not necessarily the full credit, even though you guys are giving the right answers. And so part of it comes down to your justification in picking histogram K. So you guys are doing a really good job of explaining, hey, histogram K is skewed to the left. And when you're skewed left, the mean is typically lower than the median. So that's how I match it up. Generally, when you have to make a choice in AP Statistics, you not only need to defend your choice, but you need to explain, even very briefly, why the other choice is incorrect. So something like, when the mean is lower than the median, that typically means a graph has a left skew. Histogram K has a left skew, while histogram J has a right skew. Therefore, the more likely group that walks to school is represented on histogram K. Something like that. Instead of just talking about K and why K is right, be sure to give a brief shout out to why the other one is not right. And in part B, you guys are correctly using the word bimodal. But when you're only describing a shape, you want to give a little bit more context to why it's bimodal. And it helps to also indicate where the clusters would be. So instead of just saying, oh, the graph would likely be bimodal, you could say the graph would appear to be bimodal with peaks at around 8 minutes and about 40 minutes. And I know that seems kind of petty, but as I mentioned, I'm going to show you some answers from where I drew inspiration from. I believe, where is it? Which one is it? 2018, this is the one. Okay, so right now you should see part A, they had group R and group S, but you have to state that histogram 2 is more likely to be a certain group. So like saying K is like the walking group. Refer to the fact that R should have longer completion times, which is us making the claim of like, oh, when the median is lower than the median, we're probably skewed to the left. But then you have to justify the choice based on a comparison. So you do have to mention both graphs. Ooh, let me make this bigger so you guys can actually see what I'm talking about. So 1, 2, and 3. A lot of you guys are doing equivalent to 1 and 2, but not that third thing where you justify the choice based on a comparison or a mention of both. And then in part B, which was similar to this, okay, you have to state the shape would be bimodal and provide some kind of description of the peak. So you could potentially sketch a graph or explain where the peak on each side would be. So they do say, note the distribution will have a distinct peak on each side. So I realize a couple of you did that. But if you just said it would be bimodal and didn't give a reason for it to be bimodal, that doesn't necessarily count. You're still going to get partial credit, but not full credit. For part C, okay, it asked you to describe the sampling distribution for 500 staff members. I believe it gave that. On the rubric for a similar question to this, you'll notice you need the mean, you need the standard deviation, you need approximately normal as a shape, and you need to justify the shape with why you can say approximately normal. Okay, and if I show a sample answer that I got today, I'm going to be switching back and forth between tabs a lot, so I appreciate you guys kind of sticking with me here. This came from our friend Brandon, who's often in this group. So Brandon mentioned the mean of X bar would be 25 minutes. Okay, so he's got the center. He mentioned the 10% condition, which is not necessarily something we need to double check. We need to check that the sample is large enough to justify approximately normal. So he calculated the standard error, which is correct. 3 minutes is the standard error in this case. And then he described, okay, so in this simple random sample, the sample mean time will typically vary by about 3 minutes from the true value mean time of 25 minutes. So he gave a description of center, he gave a description of spread, but he did not give that description of shape with the central limit theorem justifying this. So again, sorry, it's a little small. I got to remember to do both things there. So Brandon would get partial credit on this because he's got the center and the spread calculated correctly, but he does not have the shape and the description of y. All right, so let me pause here and see if anyone's got questions on A, B, or C, okay, of the descriptions I've given for A, B, and C. So A, we picked histogram K and explained why it can't be histogram J. B, we're giving bimodal and including a description of why we have either peaks on both sides or describe where the peaks are. And in C, we're doing our sampling distribution calculations of mean, standard error, and invoking the central limit theorem because 36 is bigger than 30. Any lingering questions there? And if you don't, you can just put a little like thumbs up or I'm good kind of in the chat. That might also help me realize, okay, we're good to go. I can keep it moving. Okay, thanks y'all, appreciate that. Yes, thumbs up emoji, excellent, 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 excellent. All right, part D, okay, asked us to, I believe it was identify which test we should use. I believe that was, yeah, describe the kind of test we want to do. So we want to compare the mean travel time for teachers versus the mean travel time for students. So that is a two sample t-test, and everyone I've seen who has given me answers so far has done that. 2 sample t-test, and writing out hypotheses. Remember, based on Monday, we know we need to write out the descriptions of the hypotheses, or a description of the parameters, excuse me. And everyone who submitted answers so far I've seen say things like, you know, let P or let mu, whatever label you want to use, equal the mean travel time for all teachers and the mean travel time for all students with labels. So that is definitely been a good thing there. And then part E, once you name the test, we're looking for questions, if the conditions are met. And so in this case, the conditions are met, okay? There's 2 independent random samples, Katie, I'll get there in a second. 2 independent random samples, both samples are bigger than 30, so the sampling distribution should be approximately normal. And the 10% condition is met because it's reasonable to assume that, oh, that's not good. It's reasonable to assume that the population of students is at least 400 and the population of teachers is 500. They tell us that. So we're at the, okay, that's good to know. We're under the threshold that we need. So all 3 conditions, check, check, check. We needed to check 10% here because it is sampling without replacement. Remember, we don't check it for experiments, but we check it for sampling without replacement. Katie, what I tried to do is I did not use previously released College Board questions. I based some of my questions off of similar ones, but I tried to do it where these wouldn't be ones that you'd be like, oh yeah, I remember seeing this before, because I know sometimes a lot of teachers will give, you know, real FRQs throughout the year. So I'm not going to have like links to like, all right, here's the specific rubric for this specific thing. And I realized I probably should have kind of written some out. I just was going to kind of talk to us about it. But during the Cram, the 5-hour Cram finale, I talked with the other teacher who's going to be leading the first half, and we agreed that we are exclusively going to use previously released free response questions so that we can give kids links throughout the presentation if they want to like go back and double check things. So Monday, you'll get another original question from me, and I will very clearly make a rubric for it. But next Thursday, we'll be only using released free response questions. All right, so 5 parts. You see we're pulling from a lot of different places, okay? Parts A and B are all unit 1, kind of describing distributions, shape, center, spread, what's going on with them. Part C is sampling distributions, and then part D is about hypothesis testing. And if this were a 25-minute question, I could very easily see a part F where they then give you the p-value for the test was this, and you have to then make a conclusion based on the parameters and hypotheses you wrote in part D, and that you check the conditions in part E. Okay, so with that, that is scenario 1. And scenario 2 was about a common activity in physical education classes, the beep test. Oh, I'm sure you've all done the beep test before. We call it the pacer test, at least at my school, we call it the pacer test. Oh yeah, it's a good time. So each time the student successfully beats the beep is called a rep. A student in a large high school recruited 50 other students to participate in an experiment to determine if playing motivational music during the beep test would improve performance. The students were randomly assigned to 2 groups. The group completed the beep. One group completed the beep test with motivational music, and the other group completed the beep test without anything being played. The groups completed the test without seeing the other group compete. And then we've got a nice back-to-back stem plot to show the results of the beep test. Speaking of, I found this gem today.
It's a multi-stage aerobic capacity test that progressively gets more difficult as it continues.
So I'm just
the
going to...
20-meter pacer test will begin
This
in 30
probably brings
seconds.
up some bad
Line
memories
up
for some
at the
folks if you
start.
can hear
The
what's going
running
on in the
speed
background
starts
there.
slowly, but gets faster each minute after you
So
hear
just like
the signal.
before,
A single lap
I'm going to let this go.
Time you hear this sound.
Going to let this go for about 5 minutes for some folks. Again, you can see these all
The second time
on the
you fail to
document.
complete a lap before the sound, your test is over.
Uh-oh, your test is over. All right. We're not going to actually do the beep test, but that is always a good time. So I'm going to give us another about 5 minutes or so to take a look for those that hadn't looked before. And we will come back together at 9:30. It's 9:24 what I see, so we'll come back together at 9:30. Again, you can toggle through on the document, and you'll be able to see these questions. I'll see you in 5 minutes. All right, going to come back here in about 30 seconds. All right, 9:30. Noticing a couple of answers down in the chat. Okay, good. Appreciate that. All right, so for part A, okay, basic probability question. Okay, you had to identify people who first did less than 100 reps, period, or then less than 100 reps, given that they didn't run with music. And so in both cases, we are just going to count and divide by the total that are eligible for each situation. So in the first scenario, if I draw a little horizontal line right above 100, I would be able to count 10 folks on both sides, 3 on the with music side, sorry, 13 folks, excuse me, 3 on the with music side and 10 without music, for a total of 13 people out of 50. 13 out of 50 is 0.26. Okay, this by itself, 13 out of 50, should get full credit this year because it is showing where the probability is coming from with that's appropriate work. If you show 13 out of 50 equals 0.26, that will definitely get full credit. But the one that won't is just putting 0.26. If you get a calculation, if you do a calculation but don't show that calculation, unless you've shown some kind of other setup or explained how you're using the calculator to do this, you're not getting credit on a probability question. Sometimes a lot of really, really basic questions go with a lot of students not earning full credit because they assume they don't have to show all the work. So stuff like adding, dividing, setting up fractions, you have to show that on your paper to get the full credit for the probability scenario. And so the same for part B, or for part 2 of that, 10 out of 25 or 10 out of 25 equals 0.4. Both of those would get full credit, but just a straight up 0.4 does not get full credit. Okay, part B, you were asked to compare the distribution of reps completed for the 2 treatments. Okay, I'm going to pull up a sample answer I got this morning so I can talk about what's quote unquote good about it, or maybe there won't be something good about it. We shall see. All right, so we're looking at part B of question 2, so I'll have to scroll a little bit. So this person, this was Brandon, he found some statistics at the top here. Okay, he did not need to do this, but it's not a bad idea. So he found the median both with and without music. He named the shapes of both, and he found the range of reps for both groups. What he then did, though, is the important part. Okay, by saying the median of the distribution of reps completing with music of 124 is greater than the median of the distribution of reps, which is 101 by students running without music, that's where he's getting his point. Okay, by making an explicit comparison. Remember, when you're asked to make comparisons, you have to use comparison words. So just giving all the correct descriptions isn't going to do it. He then compares the shapes, roughly symmetrical. I've seen some people say approximately bimodal. That's fine. Or also slightly skewed left. Pretty much all of those are okay for the without music group. And then he compares the ranges. What Brandon didn't need to do on this, and Katie, you just asked this, the numbers actually are optional for comparison questions. You need to show the numbers for describe prompts when you're asked to describe things. So like in 1C, when we did the sampling distribution, we had to show the work for the mean and standard error. But for a comparison question, we don't necessarily need to say all the numbers, but you do have to actually make comparison statements with comparison words. All right. Parts C and D on this one, I think are good. Yeah, the distribution, yeah, skewed left slightly is fine. I think, so this is where I'm getting myself into like a little bit of trouble here. The real AP exam, so I kind of changed the scenario that was actually given on the real AP exam here. So this was a multiple choice question on a real AP exam. Shh, we're not supposed to use those. Let me pull it up again. And on that, the number of individuals was not the same on each side. So I went ahead and added a few more numbers to the right side. You actually might be able to see where they're a little offset. That was my MS Paint, attempt at trying to edit the prompt. And I realized after seeing some answers that it went from a clear left skew to more of a bimodal-ish kind of look, but it does have a left skew. So I'm willing to think that if you're making a comparison, if you say something like with music is skewed to the left while without is less skewed, or possibly symmetric or slightly skewed, like I think all of those are going to be accepted in terms of the shape. But I agree, it does have a slight left skew. So that's where I'm like, that's not the greatest example. But the idea is you just need to mention both shapes, but you need to explicitly compare the medians and the ranges if you're going to do that for center and spread. Okay, parts C and D are where things get interesting. With music is less, yes, with music is left skew. Okay, oh, I wish I had a piece of paper with me. What's hard about this is you might be tilting your head and looking and seeing a tail on the right side. Okay, but if you do, look really carefully, because the numbers in the stem plot are now backwards, because on the left side is 140 and on the right side is 70 something. And so that number line is backwards. And so when you're looking at that and thinking, oh, there's a right skew, you're looking at it backwards. And so it's really a left skew because you're skewed to where the lower numbers are. If you're going to do a back-to-back stem plot and try to draw the little shapes over it and look for a tail, make sure that you turn to the right side, because then the numbers are usually lined up correctly. Yes, the other side has like a correct number line, and you'll be able to see the tail on both sides of the distribution at the same time that way. Yeah, no, that's definitely something I'd have to do in class and like tell kids like literally tilt it. It's going to be a thing. Yeah, thanks for asking. So parts C and D, okay, are both from our collecting data unit. And this is where a lot of students will say the right things, but not get all the credit that they deserve. Anytime you are justifying or explaining something that's about experiment design, why do we randomly assign treatments? What's a possible confounding variable? Why did we do blocking here? Did we use replication? Anything that's like that, we have to always anchor our answer in context of the response variable of the study. Okay, I think we did the example a few weeks ago with like the survey about the university buildings and grounds, and everything had to come back to what kind of estimate are we going to get about the buildings and grounds, like how people feel about them. And so in this case, everything you write about in part C and D has to remain in the context of the number of reps of the beep test you are able to complete. Okay, so for part C, I've seen a few answers so far about like, hey, the difference in the difference between the treatments was unlikely to occur by chance. Okay, I believe, in fact, I'll pull up Brandon's answer again. I think he said something almost identical to that. So let's look at this. This is Brandon's first attempt. So part C, Brandon says, statistically significant means in this context that the difference in reps between students with music in the background and without music in the background is large enough to not have occurred by chance alone. Okay, because Brandon mentions the difference in reps, he's anchored this in the context of the experiment. If he just says the difference observed between students, or the difference between the groups, or the difference between the treatments, that's not clear enough. But mentioning the response variable in this is what gives it, in my opinion, likely full credit. He can strengthen it because the test was to figure out, it would be a mean. You do a t-test probably. So you could potentially say like the difference in the median, the difference in the mean number of reps, but just difference in reps should be good here. Okay, and then for part D, we're asked why randomization is important. I think Brandon gives an answer that would probably get partial credit. So as he says, randomly assigning the participants is important because it helps create roughly equivalent groups of students by balancing the effects of other possible variables, such as athletic ability among the treatment groups. So he correctly describes one of the whole points of randomization is to get fair comparisons. You want to make the groups as equal as you possibly can, but he doesn't connect that equality to their ability to complete the number of reps. So he does mention a confounding variable of athletic ability, but then doesn't take it further to say, if we didn't randomize, then perhaps the very athletic kids would all pick the same group and be able to complete more reps with or without music. I've had other people mention people picking their friends. Okay, you can say if you don't randomly assign, people might go with their friends. Okay, if that's the case, you then need to describe how going with your friends will impact your ability to complete the beep test or to complete the pacer test. You might say, you could justify it either way there. You could say, if you're with your friends, you're more likely to be competitive and you'll try as hard as you can with or without music. Or you could say, if you're with your friends, you'll get distracted and not try as hard with or without music. So ultimately, you're trying to explain why randomizing balances things out, or why not randomizing would introduce a possible confounding variable, and how those will impact the ability of the people to complete the experiment and measure the response variable we care about measuring. Katie, when you say mentioning variability, I think if you talk about variability in their ability to complete reps or variability in the number of reps completed, that can potentially work, assuming you anchor things in something that could like be true in this scenario. So if you say, randomizing will help balance out possible confounding effects and reduce the variability in the number of reps completed for the two different groups by doing this. That should be like a boilerplate answer, but then you need to maybe give a reason for that. Naroon, yes, if you're coming up with a possible confounding variable, just mention one. You're never going to have to come up with multiple unless they explicitly ask for multiple, and I've never seen that. So I think that's like just one possibility, and then just defend your one. What you shouldn't do is try to defend all possibilities. Like, don't try to give 3 different reasons and 3 different outcomes. Just say, hey, this might happen, and this is how it would impact the experiment. And typically, you'll be able to get justification points for that. So with that, I think Brandon in part C would get full credit. I think in part D, he'd be somewhere between partial credit and full credit, depending on how generous the rubric for that year was. And with that, I'm going to pause for a moment and ask if anybody needs any more clarification on any part in question 2. So we had the basic probabilities at the front. We compared the distributions, and then we talked about statistical significance as about differences in treatments being unlikely to occur by chance, which is low p-value. That's if you talk about low p-value, you can still get credit there. And then why randomization is important. Any lingering issues there or things I need to talk about again? And if not, you give me a thumbs up and we'll go on to question 3. All right, well, I'm not sure if the people who just left thought there was only 2 questions or they got bored with me. So I'm just going to jump right into question 3. And I'm Brandon, you missed it. You missed it. We put it on. People had some flashbacks. If you don't complete within 20 seconds. All right, so scenario 3, I gave a scatter plot and the little table with all the predictor things in it. So got a scenario where we're wondering if the rent prices of 1-bedroom apartments are related to the distance from the nearest train station. From a list of 250 similarly sized 1-bedroom apartments, researchers selected a simple random sample of 20 apartments and then measured the walking distance to the nearest train station and created a scatter plot. Scatter plot and output are shown below. Okay, here are the prompts for this one. For the sake of time, we're coming up on closing in on 10 o'clock, so I'm not going to go off camera again and give extra time for this. I'm just going to kind of talk through points about the rubric on this one. Okay, so part A, we mentioned a simple random sample in the description, and you're asked to explain a procedure by which this might have happened. So this is an occasional question. It could potentially come up. The biggest issue people have with describing simple random samples is they often forget to be really, really precise about what random numbers we will use to generate the procedure. So in this case, we would need to do three things, okay? We would need to give every apartment a number, okay? And we should clarify that those numbers are between 1 and 250. So you could do your 000 to 249 or 1 to 250, okay? Then you need to generate a list of 20 unique random numbers between 1 and 250. I think what ends up happening is a lot of people will say something like, give every apartment a unique number from 1 to 250, then randomly generate a list of 20 numbers. If you don't clarify that you're doing it within the bounds of 1 to 250, you're opening yourself up to picking numbers that are not assigned to an apartment. So always number the population, pick the number of numbers you need out of the labeled bounds, and then clarify what you're doing with those numbers. So you say then the apartments that correspond to the numbers chosen will be selected and the distance will be measured and the price will be recorded, or something that explains what you're doing in the survey. It's little things, so make sure they're uniquely assigned numbers, make sure you randomly generate a list, okay, and make sure you pick out numbers within the boundaries of the population that you've identified. And that's how we do that. Okay, describing association. Every answer I've seen so far has been on the money. Okay, remember describing association on a scatter plot. You got to keep it in context by naming the variables, and then you got to give a direction, positive or negative. You got to give a form, linear or nonlinear, and you got to give a strength, weak, moderate, or strong. And in this case, I see a very clear negative, linear, strong association. I was about to say positive. That's not the right word there. Okay, and so I would say something like the association between walking distance from the nearest train station and weekly rent, including the sample, is linear, negative, and strong, or strong, negative, linear, whatever list of those words you want to use. If they don't ask you to describe the meaning of those words, you can just leave it. And so that's been something I've been seeing really good with on that. Okay, part C, interpret the value of the coefficient of determination. That's the R squared. This is a sentence template. You probably saw it. Does one have to state the linear equation? Not unless you're explicitly asked to. So in this case, they actually, I don't think they do. So they could, from this, they could very easily ask us to write the linear equation. They could ask us to interpret the slope. They could ask us to identify the slope. They could ask us to interpret the intercept. They could ask us to identify the intercept. They could ask us to interpret that S, that standard deviation of residuals, where we're typically off by about $4.43 based on the least squared regression line. Or they could ask us to interpret R squared. All of those are covered in the Unit 2 Cram lesson we did, and there is on those slides sentence templates that you can use. And I think those sentence templates are going to go on to a cheat sheet document that we make in the next week. So I'm not going to go into them too much right now. And in fact, I'm not going to spend too much time talking about part C because it's just a fill in the blank kind of template. But we'll talk about parts D and E. So in part D, okay, I gave a confidence interval. Now, technically, you would not get a confidence interval for slope this year, but I still felt it was good to practice interpreting confidence intervals in general and like what to do with them. So if the second researcher predicts that each additional minute will cause the rent to decrease by approximately $2, okay, if we look at the confidence interval, the number -2 is within that range. In other words, $2 decrease per week is within the confidence interval. And because a $2 decrease is within the confidence interval, then the researcher's claim is justified. It's not necessarily correct, but it's justified. And so we do not have evidence to contradict the researcher's claim. So the answer to our question, that's yes or no, does this contradict? The answer is no. And then we need to make sure that we're very careful in our response to not say anything that implies that the researcher is right, just that we can't prove them wrong. So it's equivalent here to, we don't accept the null hypothesis, we just don't reject it. And we never prove the alternative hypothesis, we just have evidence for it. What did you say? You said -2 is included in the confidence interval, and as a result, this does not contradict the researcher's claim. That is fine. Yeah, saying something like the researcher's prediction is correct would knock you down, because that implies that it is -2 and not just possibly -2. Kind of like when we did the confidence interval with the, there was a scenario with like a restaurant generating discounts, and like they first asked, is the program not working? And the answer was, well, no, it might. But then the second one was, okay, so is it actually working? And it was like, well, no, it might not be. So you have, like, both answers were no. Yeah, Brandon, I think that's going to be the case. I think we're going to have to just be really precise with our language in math terms. Absolutely. All right, last one. Okay, if we do a mixture of 1, 2, and 3 bedroom apartments instead of just 1 bedroom apartments, okay, do we expect this value of R squared in the second study to be greater than, less than, or equal to? Okay, I think, Brandon, I'm just going to pull up your response because it was chef's kiss glorious. Where is it? Here we go. Thanks for sticking with me. This is the one. Make it a little bigger so folks can see. Okay, I'll just read it verbatim. I expect the value of R squared to be less. Okay, so we made our choice, because by including 1, 2, and 3 bedroom apartments, I am increasing variation in my sample size, or my sampling size. Increasing variation is the reason that R squared would decrease, but then you go and very clearly explain what you mean by this in context by saying the 2 and 3 bedroom apartments may have significantly higher prices regardless of distance. The amount of variation in weekly rent dollars that is explained with the explanatory variable should decrease. Okay, you say will decrease. I think that's okay. I think we might want to say should decrease, or will probably decrease, or is likely to decrease, or something like that. But I believe that you have justified your response very clearly, and again, connected it to the response variable. Yeah, LSRL is a fancy way of saying least squared regression line, which is accepted terminology. So there are some acronyms you can use freely. SRS for simple random sample is freely available, but it's simple. You have to, if you're going to talk about stratified, you need to say stratified random sample. And you can say LSRL for least squared regression line. There's not much else that you can shorthand. Calc has some shorthands that we can use, IVT and NVT. Yeah, R squared. Okay, that should count as a shorthand. I'm trying to think, but like otherwise, there's symbols for pretty much everything else. Yeah, there's symbols for pretty much everything else. So you would use the appropriate symbol or the appropriate name. Okay, and so with that, okay, those are our 3 scenarios for tonight. And oh, look at this. I am so good at figuring out timing because we are at about 9:52. So I'm going to pause here and just do kind of open Q&A at this point. And I'll remind you guys that on Monday, I'm realizing that I should have had some sample answers embedded into the PowerPoint and built the rubrics in here. So I apologize if you're looking for maybe some more examples and I don't have them. I'm not able to point you to them at the moment. I'll do better on Monday. But on Monday, we're going to come in cold. So I am going to just time you live with a scenario that I will link to when we start. And then I'll have the rubrics and we'll talk about our sample answers after you guys do them live. So that'll be Monday. And then the Cram finale will be lots and lots and lots of previously released free response questions with some quick hits from each of the units. Brandon, full disclosure, these 3 scenarios are community prompts. So I had noticed that a lot of the, no, it's fine. I noticed that a lot of our crammers had not done the mixed practice ones. And so I just was like, all right, let me just take them and make you guys do them. So don't worry about the mixed ones. I will potentially release a couple new ones next week, but I will not be releasing the ones that I make for our Monday session before Monday. So you're going to come in cold on Monday no matter what and practice live. I think that will be a good use of our time. Yeah, no, and I'll send a couple reminder emails and stuff for folks. And so now I'm at a point where I think we are good to just kind of do some Q&A. If anybody has any requests for units that you feel you need a little more help with, Narun, I know we talked about potentially you had some questions about probability that you can chat me and I'll try to answer. Otherwise, thank you guys so much for coming out. For those of you that were doing the practice in advance, I hope you guys got some good feedback on your answers. Those of you that did not, I hope you were able to get a sense of what kinds of questions might come up and be ready to practice on Monday. And I appreciate you guys being here. So I'll stick around for some open Q&A on the chats. Otherwise, have a wonderful, wonderful evening. All right, so Brandon, I don't, to be honest. I think things that are pretty formulaic like that are rare enough as is, given how many questions there aren't going to come up. So I cite, for example, I also teach AP Calculus, and AP Calc this year got reduced to pretty much just, here's a graph of a derivative, do a bunch of stuff with it, and here's a table of data, do a bunch of stuff with it. And that included some, derivative rules, antiderivative rules, and I don't know if you've taken calculus, but there's, some stuff in there. But most years there's an equation question and a scenario that's in context, and you got to do a lot of stuff. There's only 2 questions this year, so they're going to reduce it to what's the basic level of questions they can ask that allow you to demonstrate your knowledge of statistics on a more holistic level. And so while I think there will definitely be a question where you are interpreting a p-value, combining independent random variables doesn't feel to me like it's the most important thing for you to be able to demonstrate your knowledge of AP stats, especially because there's a formula for it and all you'd have to do is look it up. It's not something you'd have to remember to bring with you because we're, not using formula sheets. Exactly. I'm with you there. I do think it's possible that you might have to describe why a situation is or is not binomial, but I don't think you're going to be doing a full, 2-part question on, doing a binomial probability or doing a geometric probability or describing those distributions. I just don't think it's very likely. I think we'll get, my personal guess is one scenario is going to be a description of a observational study or an experiment with 2 graphs that you then need to make comparisons of, and then need to describe, what hypothesis test to do or interpret a confidence interval. And the other one will be the other inference procedure that wasn't tested on the first one with some other stuff. So like, for example, the 25-minute question might have describe these distributions, talk about what kind of, experiment this was, and then do a bunch of hypothesis test things. And then question 2 will be find these probabilities, make these comparisons, and oh, by the way, here's a confidence interval, do something with it. That's my personal guess. We'll see. So that's where I think we're at. So yeah, Narun, you said you had questions about probability. Can you kind of say what clarification you needed on those? I could potentially find some old slides to look at the moment. But I know you had emailed me. Yeah, you emailed me. So, and Tejas, if you're still here, if you have a question, put it in the chat. If not, you are good to go. Narun, actually, I think this is going to be, do you have questions that you'd like to ask verbally? Would that be easier? Because we can end this crowdcast where you can't talk to me, and I can send you a link to something where you would be able to talk to me offline. Okay. All right. I will send you a link in your email in about 5 minutes. All right. Let me just wrap this up. If you're watching on replay, thanks for watching, guys. We will be back Monday the 18th with our live practice session. Thanks for coming.